Alright, hi guys, this is Mr. Loknen, and we're going to be doing a lesson today on right here, exponential growth or decay models. Alright, so this is our lesson for Thursday. So this is our third lesson, the chapter, and it's actually a pretty short one. Alright, so if you're taking notes, this is the biggest thing right here. Alright, drawing that. Not drawing that, but copying that down. This equation here is we're going to be doing basically everything through that equation, and then this right here is what all those variables are equal to. Alright, and so we'll be referring back to that as we do this entire lesson. Also, it says growth or decay factor is blank, and we're just going to be writing 1 plus or minus r. Alright, it's similar to when we did graphing earlier. Remember the growth or decay factor was b. It's basically the same thing. We're just replacing that b with that 1 plus r. Alright, so that is the growth or decay factor. So this equation is what we'll be using this entire lesson. Alright, so we have just 3 examples, not too bad. It tells us, first one, in 1970, the population of Kern County, California, where Bakersfield is located, was about 330,000 people. From 1970 to 2000, the county population grew at an average annual rate of about 2.4%. Alright, so the first thing that sticks out is this word grow, or grew. That tells us we're going to be dealing with a growth, exponential growth model. All that tells us is that when right here it says plus or minus, we're just going to be using just plus. Alright, so we're going to do plus r. Alright, so all we have to do is we take this this equation here, and I'm just going to replace all those variables with what it tells us in this problem here. Alright, so instead of writing y, I'm just going to write p, because that tells us the final amount. That's what we're trying to figure out. So I'm going to go p equals a, and I know a is the initial amount, so how much should we start with? The city of Bakersfield started with 330,000 people. Alright, so that's what a is equivalent to. And then we're going to write 1 plus r, and remember we learned it's plus because it's growth, not decay. So we're going to go plus r. Alright, so r is the rate, so anytime we see a percentage, that's always going to be r. Alright, so here's the tricky part. I see this happening a lot where it's 1 plus, we just write 2.4, alright, because that's what the percentage is at. But remember, this r is referring to the rate as a percentage. Alright, so what we have to do, we have to convert it into a decimal. Remember, 2.4% converted to a decimal. Remember, we just move it 2 spots to the left. Alright, so what does that tell us? That tells us the decimal is 0.024. And then t, we're just going to leave that because that's what we don't know. So that is our equation. Also, one quick step to make it a little easier, instead of writing 1 plus 0.024, I'm just going to combine that to make that 1.024. Alright, and then what we're going to do, it tells us about how many people lived in Kern County in 1990. So all we're going to do is we're going to take this equation and just plug in what we know for t. Alright, so we got to figure out how many years after 1970 is 1990. We just go 1990 minus 1970, which just gives us 20. Alright, so that tells us, I'm just going to replace this. I'm just going to rewrite this equation. But instead of writing t, I'm going to write that 20. Alright, and then you just need to type that in your calculator. And we do order of operations. So we would first need to type in that 1.024 to the 20th power. Then we do exponents first, and then we'll do multiplication. Oops. So we would go 1.024 to the 20th power, and that gives us 1.607. Then you multiply that by 330,000, and we end up getting 500 530,289.55. Now, obviously, you can't have 0.55 of a person, so I'm just going to round that to 90. Alright, so that tells us after 20 years, that city would be about 530,000 people. 530,290 people. Alright, so that's that first. Oh, actually, we have part C to do as well. So all we're going to do here is we're just going to take. Oh, I have it written down already. Look at that. So we're just going to take that equation. Notice how I took this equation, the one that's written on part A, and I just copied it into my Desmos. Make sure if you did not download Desmos already, make sure you do that. Alright, it's a free graphing calculator. Works just as good as a regular graphing calculator. And the only thing we do different is instead of writing P and T, you just write Y and X. So after you do that, you'll have to kind of, this is what it looks like when you type it in. Obviously, you can't see anything, so you have to zoom out a lot till you start to see the line. And then what we're going to do, we're going to figure out where it crosses 400,000. Now, 400,000 is right in the middle there. And then we figure out how many years. Looks like it's about right there. Right there, about 8. Alright, so what I'm going to do, I'm just going to write 8 years. So it's 8 years after 1970. We figure out it's 1978. So that would be that one. All you're doing is just typing that into the graph and figuring out where it crosses. Next, example 2, it tells us the new car costs $25,000. The value of the car depreciates by about 15% each year. Write a model giving the car's value Y in dollars after T years. Alright, so we're going to do that same equation. Instead of writing P, I'm just going to write Y this time, because that's what it tells us. And then we're going to write the initial amount. The initial amount the car is worth $25,000. And then we're going to do 1 minus. The reason why we're doing a negative is because it depreciates, or it goes down. So we're dealing with decay here. So we're going to go 1 minus 0.15. Remember that we have to convert that percentage to a decimal. Alright, and then we go that to the T power, T representing years. Alright, and then what we're going to do is one quick thing. We can reduce that 1 minus 0.15. Just to make it easier, we can make it 0.85. Alright, and then what we're going to do is we are just going to take that equation and plug in a 4 for T. Alright, so I'm just going to rewrite the equation Y equals 25,000 times 0.85 to the 4th power. Alright, and then if you have a calculator, we just type that in. And then we can figure out the answer. And remember, we do order of operations, so we're going to do this first. So we go 0.85 to the 4th, 0.85 to the 4th power, which gives us 0.522, and then you multiply that by 25,000. We figure out it's $13,050.16. Alright, so that would be our answer. Alright, and we're going to skip example 3 because that's exactly the same as example 2. Alright, so hopefully that was not too bad. Let's make sure we are getting done with that assignment. Shouldn't take too long. If you have any questions, make sure to please ask myself or Miss Erickson. We would love to help. And yes, alright, so we'll talk to you tomorrow. Peace.